Okay, so in this video I'm going to look at the relationship between potential and field strength. So an equation you should know that applies to all the fields, whether uniform, radial, electric, gravitational, is that the field strength is equal to the minus change in potential over the change in radius. So we're going to look at how we can apply this to actually find the link between potential and field strength. Okay, so we need to rearrange this slightly to get the delta V on its own. We're going to get minus E delta R. Okay, so if we want to actually solve for what potential is, we're going to need to do an integration. It's going to be integration. Now if we remember, the potential is the work done from infinity to a set point. So it's going to be between infinity and R. And put the minus sign at the front, E delta R. Obviously we need to write E in terms of R, so that's going to be the integration between infinity and R of Gm over R squared delta R. And as G and M are not functions of R, we can move those outside. Gm integration infinity and R of 1 over R squared delta R. Okay. So first let's consolidate that over here. So V is minus Gm integral of R to the minus 2, so we're just changing 1 over R squared into there, and dr. So now we're in a position where we can actually do an integration, which equals minus Gm, or minus 2 is going to go up to minus 1 when you integrate, still between infinity and R, and we're going to divide by the new power, so divide by minus 1, so we can cancel those straight off the bat. So this means that V is equal to Gm brackets 1 over infinity minus 1 over R. Now obviously 1 over infinity is going to be 0, so you're going to be left with Gm over R, and obviously it has a minus sign in front of it, and that's an equation you should already recognize. This is just going through the proof of it. Now, obviously if you do this backwards, you can prove that this, if you take the derivative of it, gives you the field strength of it. But I'm not going to do that because that's not going to be really essential, because you can just basically reverse the steps that I've already did. But the main conclusion you can draw is that field strength is going to be the proportional to potential, what's called the potential gradient. So what does that mean? Well, if we drew a graph of potential against R, it's going to look something like this. Now if we wanted to find E at any point, so say we wanted to find out what the field strength is here, it would be the gradient at that point. Likewise, if we had a graph of field strength against R, if we wanted to know what the potential is, it's going to be the area underneath it between, and this would allow you to work out the potential difference between points, if you like.